Simon Dwan, computer simulation of PK.
In science, we tend to model the perceived reality using familiar metaphors. In mechanical era, we modeled the macro universe as a clock-like machine. When human society was electrified, we modeled the micro universe as electrically charged particles. In this information age, we have new metaphors such as computer, information processing, big data, virtual reality. Not surprisingly, some scientists have pioneered the idea of a computational universe. Konrad Rose, a German computer scientist, first speculated that the entire universe is being computed on a computer. John Wheeler, the renowned physicist, proposed a very famous phrase, "it from bit." All things physical are information theoretic in origin. Edward Fredkin suggests that there is this place, he called other, that hosts the engine that runs the physics. In recent years, the speculation has been taken increasingly seriously by prominent thinkers, including philosophers, cosmologists, physicists, biologists, and technology leaders. To progress from speculation to a scientific model, we need to address some key questions, such as where is the computer and what is it made of? To address the first question, we adopt an insight from arguably the greatest philosopher of all time. Whitehead once commented, "The safest general characterization of the European philosophical tradition is that it consists of a series of footnotes to Plato." According to Plato, physical existence is a shadow or poor imitation of the ideal realm of existence. Archetypes exist in the realm of forms and operate as the fundamental reality. Material objects in the physical reality resemble their perfect archetypes to varying degrees. For every mundane material existence, there is a corresponding archetype in the realm of forms. For example, dogs of all shapes and sizes in the material reality are poor imitation of an abstract archetypal dog form. Applying the same principle, we locate an abstract, non-physical computer in the realm of forms. We call it the Platonic computer. We hypothesize that it is the Platonic computer that renders the physical reality. That is, the cause of the material world is the Platonic computation. The introduction of a Platonic computer allows us to build a causal chain of PK as following. PK agent interacting with the Platonic computer causes parameter changes in the Platonic program, and manipulating parameters in the Platonic program causes phenomena of PK. In science, hypothesis needs to be tested. But can we test this hypothesis? Traditionally, we test the hypothesis through physical experiments. Nowadays, scientists increasingly use computer simulation as experiment. Indeed, computer simulation is now accepted as a type of experiment and is used extensively for studying complex systems that are difficult or impossible to replicate in a laboratory setting. For example, in astrophysicists, hypotheses about evolution of the universe, the structure of galaxies, and the behavior of black holes have been tested through computer simulation. Simulations in particle physics are used to test the hypothesis about the behavior of particles. In parapsychology study of PK, we are not able to reproduce the desired results on demand. It is also challenging or even impossible to impose an appropriate level of control on the mental state of PK agent. We therefore propose the use of computer simulation as a supplementary experiment tool to approaching PK. With a physical computer, we can simulate PK at multiple levels. At the source level, we can simulate a PK agent interacting with a Platonic computer through human-machine interface. At the programming level, we can simulate manipulating parameters in Platonic computer through manipulating parameters in mundane computer program. At the phenomenological level, we can simulate real-world PK with virtual PK. Here is an example of human-machine interaction, which simulate a PK agent interact with the Platonic computer. At the programming level, we can manipulate the parameters in the mundane computer program, such as gravity, rigidity. For example, with gravity and rigidity on, we can simulate how a physical apple falls and bounces on the table. By turning gravity off, we can simulate levitation. By switching rigidity off, we can simulate a solid object passing through a solid barrier. By switching visibility on and off, we can simulate appearing and disappearing of a physical objects. In summary, we propose that PK can be modeled as the processing output of the Platonic computer. The hypothesis describes a two-stage causal chain of PK. First, PK agent interacting with the Platonic computer, causing parameter changes in the Platonic program. Second, manipulating parameters in a Platonic computer renders phenomena of PK. The proposed causal chain of PK can be tested through computer simulation using a physical computer. Thank you for your attention.